Welcome to Data BS, a show dedicated to tackling the big questions impacting the world of data and ML/AI without any of the BS. My name is James Winegar. Each week I sit down with guests from across the data ecosystem to unpack how they're shaping their businesses or the businesses of others through the real-world application of data engineering, ML/AI, infrastructure, analytics, and more. No fluff, unfiltered, but slightly edited to remove noise. This is Data BS. Let's get into it. All right, David. And so it's nice to talk to you finally. We've been trying to schedule this for a while. So tell me who you are and what do you do?
Thanks. Yeah. Thanks for dealing with my terrible schedule, post-baby schedule. But yeah, I'm Dave Yaffe. I'm the co-founder of Estuary. We're a real-time data company. We make it hopefully really easy to capture data from a whole bunch of different business systems, applications, databases, file stores, stuff like that. And then use it for like practical purposes and real time for whatever a business needs to do, like analytics, operations, or AI.
So the underlying open source framework is called Flow, if I remember correctly, right?
Yeah, it's like kind of complicated, to be honest. The genesis story of the company is that myself and my co-founder, we had built a previous company called Arbor. And Arbor was in the MarTech space. So I always believed that in MarTech, you needed real-time data. The reason was because if you're going to a website and searching for a pair of shoes, you probably want that pair of shoes right now. You don't want it like an hour from now. You probably already bought it in today's world, an hour from now. So if you want to actually have any actionable sort of data, you got to use it immediately. We built this streaming system called Gazette to be able to enable using that data immediately. And Gazette is the thing. After we sold Arbor, we said, hey, we have this resource, Gazette. We should really do something with it because working with real-time data otherwise is super hard. And I think we can make it a lot easier.
And then Gazette turned into Flow, which is the framework in which Estuary sits on now to basically run these data pipelines off of CDC or, things like HubSpot, etc. So what's the complexity that Flow's looking to solve?
I think it's really that businesses have data in a lot of different systems. The really high level is that, they want to connect this data for uses like analytics and AI and other things like that. And if you click one level down, the way that that actually gets solved right now is people are using various different technologies and applications to solve those problems. One is for the analytics side, you're probably going to start with a tech provider like Podtrain who helps you connect your data sources to a warehouse. And then you can do search or querying in your warehouse and get answers to your analytics questions. But businesses usually will build bifurcated solutions to solve the same problem. And if you talk to the software engineering side of the house versus the data side of the house, they have two different ways of solving that, right? Like the software engineering solution is usually like the Debezium plus Kafka, whereas the data side might be like Fivetran or something equivalent. And so our technology, the goal is to make it so that you can use one thing to solve all of those types of problems because it both handles the real-time nature and also the batch nature that you want for analytics growth.
And with like the majority of integrations within Estuary, at least as a user, I feel like you push towards the real time, but the complexity of the real time is abstracted away from you. So yeah, some of the integrations are, every 2 hours or whatever, because it's a batch process that needs to run just by nature of the problem. And then some of them are supported by real time, maybe CDC or time-based like iteration. Give me everything that happens since this last timestamp I pulled against, keep going through that process.
Yeah. And what we do is our goal is we can only use like the APIs or endpoints that we are made available from a system. Our goal is to make something happen as quickly given those endpoints. So for serving batch APIs, they update the data from the source every 24 hours. So we can't get any faster than that. But a lot of systems like CDC, you can actually extract data with millisecond latency. So, as long as we're moving as quickly as we possibly can, given the API, that's really our goal.
So in our use case, we've got SQL Server, got to subscribe to, 500 different tables in the database, just, keeps going through the poll. So because we have 500 different tables on that thing, it takes a few seconds. But, if we said, hey, we only need these 10 tables, now the polling can be tightened up. And then, we could get tens of millisecond type of response time from event happening in the database to it hitting our data warehouse. And then, we could do even more interesting things from that point where, we kind of run like, a reverse ETL job or something like that. Once we get like that event message that comes over and says, hey, we had an insert happen on this table.
Exactly. Yeah. And that's an interesting use case, right? Because even with databases, it's all different, right? A SQL Server, Microsoft creates this method called change data capture, which isn't like all other change data capture. It's its own special snowflake. And the way that data is replicated, so you actually have to query individual tables one at a time to get the answer of what's going on with newly replicated data. Most other systems have write-ahead log, and every single event just appears there one after the other. So there's no querying that's involved. So that's just a good example of like one place that latency is introduced by the vendor, the database creators method for extracting that.
But given that, we do as much as we can to make that data available as quickly as reasonably possible on our target system. So, high level, make it as quick as possible when we can make it as quick as possible. When we're forced by the system to batch out because API definitions or whatever, then, you guys support that as well. So you have this single system with a real-time first viewpoint, but supports batch workloads or batch data extracts as necessary. You can really do some interesting things. Like actually I was on Slack earlier and saw somebody replicating from BigQuery to Postgres, which is not the direction I would normally be going, but maybe there's some justification for that. Like, they get data shared from a vendor, and then they're wanting to push that down into an application layer to support something.
Yeah, and even if we go back to the previous example of like SQL Server to a warehouse, we extract data continuously, basically. But we can also introduce delays with pushing to your warehouse where we're not pushing on the weekends, for instance, if you don't care about that data on the weekends. And we're only pushing within certain hours on the weekdays. So that, people are looking at reports only sometimes of the day. You don't need to drive that warehouse and eat up merge queries or expenses or Snowflake credits or whatever it is during those other times.
Yeah. And so like you have like this good separation between like data capture and materialization of that data that you captured. And because you offload the state, to like an S3 bucket or blob storage, whatever, like you're able to just go, okay, here's the last file I did all the bookkeeping on, etc. You handle a lot of the complexity, basically. So all that complexity around like, here's the source data. Did I land it yet? Yes or no? Not really a thing that the end user really has to care about because, it lands in the blob storage and then you process it and you have all the watermarking, etc. Based on, the moving pieces. And it's really powerful from my experience. So from the perspective of the system, right, you built Gazette, which became Flow, and which is the system to support moving data from point A to point B, basically. One of the things I noticed when I was like working on something with your team was that like you pretty much have like a super pluggable system as well. So if like Multano or Airbyte or whoever supports that data source, then you also kind of inherently support that data source. So are you seeing that like the investment in time in supporting multiple different kind of sync providers is providing you faster time to market for some of these connectors?
I think this is a really weird and evolving area for us. What we found is a bit counterintuitive, I would say. That was the reason that we invested in being able to run Miltano or Singer or Airbyte connectors. But what we found is that they're a little bit difficult sometimes because open source connectors are built by a lot of different people, right? There's an individual engineer that made design decisions to create that open source connector. And inevitably, for a bigger use case or a different use case, there's something that's broken with their open source connector. So it takes effort to actually be able to then advance those, evolve the connector. And sometimes what we found is since an individual connector wrote that to some specification that no other connector is built towards, it can take a lot more credits, like engineering resource credits, to contribute to someone else's code versus just writing it yourself from the ground up. And so we've had this push in recent months and years to actually build our own connectors. And it's because even though there's a bigger time sink up front, over time, they take less and less effort to keep going. And they're all built to the same specification.
Yeah, the maintenance burden is reduced because you have a specification that's working for Flow itself.
Yeah, and we have our own CDK. And so our CDK is where all of our effort's going into now. APIs are all different. Like, no matter what anyone tells you,
Yeah.
there's no such thing as like a REST API that someone built a really good, connection to. Strike has things that, aren't correct when it comes to the actual integration of like REST. And, they're an amazing developer focused company. So that means that small connectors are going to be even worse. And so what we found is we can invest in the things that look like each other. And as long as our CDK has the option to drop in a thing that looks like this here and one that looks like that there, then it can really enhance the speed with which connectors are developed.
And then that means your time to market or your ability to like onboard a new customer who has a unique data source makes you more attractive as a vendor. Then, Fivetran probably has to go through a lot more product kind of specification work prior to onboarding a source that they manage themselves. I mean, they only recently started allowing third parties to publish out their own connectors, probably because they feel some market pressure from people being able to move faster underneath them because they've gotten to such a big size now.
I think so. I think there's a philosophical difference, right? Like we have three main categories of connector development. You have open source, which arguably you can look at the numbers of connectors by the open source platforms out there. They haven't exploded in the way that they predicted that they would explode, right? Like I remember when Airbyte first came out, they were like, we're going to have 500 connectors in our first year. And you look at them now, they have like 35 total connectors that are approved by Airbyte. So open source is one. The second option is like what Fivetran does, which is they have an engineering team for each connector, right? And that's not sustainable either, right? You're not going to be able to do that except at very massive scale. And then the third is doing something more like a CDK that helps you develop connectors and look at commonality to implement them across different options. And that's where our shed is.
So could you like walk me through some use cases that Estuary has been deployed at and what basically differentiated Estuary from other vendors?
Yeah, so I think our most basic use case is like CDC and ELT. And so we have literally hundreds of customers that use us for that to access their data in real time. Some of them don't care about real time. They just want to point us at the data and say, put it in this warehouse over there. So the concept there is to just aggregate that so you're not querying data in your database or querying your individual SaaS applications. You're putting it all in one place, able to query it there. Going one level further down, we have real-time data products, I'd say. So these are things that are more like customer in the loop experiences. So these are like, a good example would be we work with a logistics company called Block Freight, and they have a need for connecting their on-the-ground people who are actually working through deliveries to the package themselves. And those, you don't want to be off by 10 seconds with that, right? You want to be like truly real time and be able to connect those so that the handoffs happen really quickly and easily. And for something like that, you're doing something more like creating a data product, which is creating a real-time view of where the package is to an individual driver. So that's, maybe one more example. A third use case could be AI. And you can actually, once you have that data that's been curated for usage, like in a real-time use case, you could then push it to a vector database, vectorize it, and use it to maybe drive a chatbot so that now you have a real-time chatbot that you can potentially just query with by asking it English instead of SQL.
There's a lot of details wrapped up in that.
There is, and it's varying success and varying maturity, I would say too.
So on the CDC use case, what makes like Estuary's CDC plus minus theoretically better than like, what Fivetran does? Like what's really differentiating Estuary from the other competitors in the space, at least for the CDC side?
There's a lot there. It's a lot to unpack, actually. Fivetran is a very stable product. It works well. A few things that we do differently that I think drive success. One is we are not a point-to-point batch solution. And so that means that we can grab lower latency if the customer cares about it, right? So that's just one example. Another is that since also driven by the fact that we're not a point-to-point batch solution, if we're reading from a database that stores the write-ahead log for a period of time, like Postgres or SQL Server, those are two good examples, we can actually always acknowledge the write-ahead log reads. And so the database can delete data from the write-ahead log more quickly. That enables the database to store less data and never fill up. And that's a real thing that happens with Postgres, right? The write-ahead log can lead to a lot of extra storage. So we are always making sure that no matter what, we're no more than a minute behind the actual write-ahead. And we do that through a bunch of different things that we offer. But one is that we have a heartbeat. So we have this capability to write to a table that we manage. And we just write one record every minute if you use this capability. that record enables us, and when you see that record come through the edit log, we can acknowledge everything after that because we know we've read up to that record. So that's just a strategy that allows us to delete data really quickly. Whereas if you're using a batch solution, the fastest that they'll ever delete something is their sync frequency, which might be 15 minutes, it might be an hour, it might be a day, it could be a long time. And then if you can't connect to the destination, they have nowhere to write that to. So we can always write it to cloud storage if you connect your cloud storage. But they might have trouble writing it anywhere if your Snowflake password is down or something.
You decoupled like the extraction of data from the writing of the data. And so that decoupling allows you to basically like, I'm going to handle all the stuff I need to on the source, and then I'll worry about like what I need to do with that as like a secondary stage. So you can fan out as well. So you were talking about point-to-point batch solution, like it's point to many points, right? Like, you're allowed to fan out.
So that's actually a cool use case too, right? We see customers that start off just writing to Snowflake, and then they say, oh, I have a real-time use case now. And how can I accomplish that? They don't have to create another capture. They can just read from the same data and push it to a new destination.
Yeah, like if you have some API you're consuming, hey, it goes to Snowflake, and then it also goes to things that support those types of use cases.
So we also have a Kafka broker, so you can pull data from our Kafka broker. And then anything that speaks Kafka, we can write to that.
So what was the primary reason for going along the Kafka broker way, right? Because I think that enables like a lot of interesting use cases. So what really drove you to invest the time in that?
There's a lot of long-term strategic decisions there, right? Like imagine if you didn't need to have Kafka within an organization. That's, realistically something that could happen in the future. But short-term, this enables any integration with systems that support Kafka. So we got Tinybird, ClickHouse, Startree, Single Store, a whole bunch of these partners that we would have had to build individual integrations with each of them to be able to do that versus one Kafka endpoint that now supports that, Materialize, and so on and so forth.
Basically, you went, oh, why do I need to rebuild all these connectors for every little thing? If I just support Kafka, I get all of these destinations for free, effectively.
Exactly. Yep.
So are those the things my customers care about? If yes, like this engineering effort was worth it. But one of the things me and you talked about before also was like Oracle, which I see as a place where a lot of the newer solutions don't play as well with Oracle because Oracle is painful to work with unless you're Oracle. So what is Estuary's kind of, opinion on dealing with Oracle?
I think it's a great opportunity. And it's something that we do as support. We have 2 Oracle captures, actually. One batch capture and then one real-time capture that does CDC. So yeah, we support Oracle. It's first-class connector now. So like it, we also support NetSuite, which is an Oracle product. And that was another really big one to build, but it's up there now too.
Yeah, it's because it allows for just generic kind of like endpoints you have to be able to subscribe to effectively.
NetSuite has 2 integrations. One is an API integration, and it's super limited. So the API endpoint is actually pretty straightforward to build an integration with, but you can't get that much data out. So any bigger customer needs the database. Underlying NetSuite, there's an Oracle database, and there's no real exposed ODBC driver or something like that you can pull data from. So we have to build our own, basically. So it turns out to be like a really big thing just because you're interacting with this Oracle database that kind of like lies to you about the shape of the data, and you kind of just have to figure it out.
I've dealt with this problem before. So like the ODBC driver is questionable. So one of the things I also wanted your opinion on, which is just the thing that like one of the reasons why we picked up Estuary originally was we have some SQL Server instances that we work with that like the schema is pretty dynamic. I would argue like people are changing stuff a couple times a day typically, and like Estuary supports automatically managing the CDC connector on the SQL Server instance, as long as you give it a role that has the appropriate permissions. And so for our use case, like that was a pretty big deal because I don't want to have to update this connector or the CDC instance on the SQL Server side like every day, and also figure out the state updates, like how to manage like did you read everything off before I go and make updates to the CDC instance.
Yeah, it's annoying. It's something we didn't do for a while, and we actually had 2 features to it pretty recently. One of them is that. The other one is automatically cleaning up data from CDC cables. So being able to, once we've read a certain amount of data, just deleting it from there. And between the two, it makes CDC really low impact, but also always have the capability to find columns and know the shape of your data change. I'll tell you, schema management has been such a long journey for us. Being able to react to changes in the database or the source system, and then be able to then manage the destination as well. So having to do stuff like widening columns in the destination system when you widen columns in the source, or changing the column type totally, or changing primary keys. And these all need like different solutions. So it's something that you don't expect to be as complex as it is, but that's something that, I think we do pretty well now.
Basically, anybody can do anything, and you don't have that insight directly. Like all you get is like the DML, right? So
yeah. And people do a lot crazier things than you ever think they'll do.
So I think that actually ties in pretty good to like a transition to talk about like the product, like from the less technical side, like how you have this UI that you've built on top of Flow that supports, kind of all of the moving pieces of like managing these different types of changes that you might deal with. And you have an underlying CLI that does all the same stuff for practical purposes. So how does this approach kind of help you manage your usability of your product?
Yeah, what we find is that most customers start by using our UI, and that gets them through like all the initial setup usually. But then there's bigger companies out there that you want to be able to know that a data flow will always be set up the same. And you want multiple people to be able to manage those, evolve those data flows. And maybe they're making changes at a large scale, right? Changing a whole bunch of different tables and the actual columns that we're pushing and the names of those columns. And it wouldn't be really feasible to make those types of changes within a UI. So our philosophy was we always need to have some sort of way to make these changes programmatically. We actually built our CLI before we built our UI, which is a bit weird. That enabled us to like build our UI on top of the same API that we use for the CLI, and that helps a lot. But I think when it comes to like mass changes, you absolutely need a CLI for these types of data flows. And also when you're setting something up so that you can be sure that it will always be the same, you kind of want GitOps, right? You need to be able to have a set of YAML files that you can put into version control, and then be able to have multiple people on the team check it as you make changes, update those, and then recheck it into version control once you've made those changes. So those are the types of workflows that we wanted to be able to support. And we see customers commonly doing those. And they almost do it in like a pattern where they start off using the UI and kind of go and take some steps towards first CLI usage and then automation and GitOps. There's so many complex pieces though, right? Like I'll give you an example. Originally, this is a really bad design decision, but we made our MySQL connector, one of the datetime types was a string, right? Like we pushed it as a string to destination.
And then that's
brutal. But now we have the fix for that is super easy, right? The fix is to change it to not be a string anymore. But a lot of historical customers are relying on that being a string. So how do you actually make an update to change the type of a field from a system where customers are dependent on it? All of a sudden you add time, like a time variable to this. So you have to track over time when something was made to understand how, if you should push it as a string or something else or whatever. And, that just brings the complexity through the roof.
Yeah, and now you got this like if statement that lives inside of your system for however long, right? And however many bad decisions you make, you have to carry them forward, right? So making better decisions up front can reduce your overall complexity dramatically. I guess like, another thing that could be complex for you is like, you have these like, Airbyte, Singer connectors that you kind of leverage, and then you're moving towards like, Estuary's CDK connection development kit to say, okay, like I want to use our CDK for MySQL connector because you're making this change, right? How do I like change over people's connector too? So it's not just like, how do I process that data, but it's also what connector is being used and those types of things.
And what do you support? You can't support every version of everything. Then you want to transition people to using the new one. You want to make that easy for them to transition. So it's hard. All that is like complexity that we didn't realize we were taking on from day one, I guess.
How long have you been working on Estuary now? It's like 7 years.
Yeah, about 6. Been a long time.
But like as far as like customers, right? I mean, it's been the last 1 or 2 years that's really started to take off. So four-ish years of building out the core underlying infrastructure to support all this complexity that we're talking about, right?
Yeah, it was a huge time commitment from a build standpoint. I mean, if we decided to just go batch or streaming instead of both, we'd divide that by 2 at least. But we chose a hard thing, and it takes a long time to get it right.
Yeah, but in choosing that hard thing, you have like the single platform that supports all the use cases. So from a market standpoint, it's probably going to be better because you're like, yes, I can work for your use case, instead of like, I only work for this one use case, but you still have to do all these other things at Fivetran. Like that's not the case for you. You can be like, no, I support, pick your API, pick your database, pick your whatever. Like we can support it. Now, does my team need to build a connector because I don't know, you're using some industry specific API that we haven't interacted with yet? Yes. Can we do it? Yes.
Exactly. And hopefully it's quick too. But my favorite thing is when we first sell to an analytics team, right? And we sell some non-real time, just standard use case. And they're probably doing something like transitioning from another competitor, I won't use any names, to us. And then later on, 6 weeks, 6 months later, someone from the team says, I was in an internal meeting and we were talking about this real-time use case. And they're also thinking about bringing on Kafka and, Confluent into BDM to solve it. And I was like, maybe you could just use what we have already.
Yeah.
And then an aha moment goes off on the company's head and they're like, damn, this actually works. We can use one tool for all this.
For one of our customers where we already transitioned them to Estuary because SQL Server support is very, very good in Estuary. We're in the middle. We have like a census sync that we're using for reverse ETL because of the other systems that are in play that are batch for reasons. Basically the same thing. It's like, okay, so it'd be better to your very first point you talked about with MarTech, right? 'Cause this is driving like a sales/marketing thing. If I can push that down into real time, milliseconds or seconds. Okay, now if we do that, we can dramatically simplify the system because we're not having to do this batch process where we're kind of, trying to figure out, like what's the latest record and, which order do we need to do it in? Like, no, we got the event, we processed the event, right? It has other simplicities that come along with it, right? And so it's like, okay, we're going to bring, those other sources into Estuary's, real-time connectors. Got to update some transformation logic and things like that. But at the end of the day, we're going to take a thing that's a 2-hour SLA, basically, to hopefully a 10-second SLA. And I think, from a practical standpoint, real update time frame is going to be 1 to 5 seconds based on, because we have this SQL server with 500 tables, right? So
yeah. Which is pretty good. That's as good as I think you can get with a SQL server like that. But I think reverse ETL is a pretty exciting thing for us. We haven't really built many of the SaaS destinations for that, but you can definitely see in 2025, we're going to build Salesforce and HubSpot and the major ones, at least, that you get used out of. And then we have a streaming SQL transformation engine ourselves. It doesn't even have to go into Snowflake or BigQuery. You can just push it direct from us.
Yeah, you already have all this supporting technology like built in. And you get the event stream, do whatever windowing is required, push. And you already have the fan out capability too. So if you want to send the same set of events to 3 different systems, okay, y'all, this is what you need to do now. Move on with your life. So what type of cost savings do you think people get with using Estuary as compared to like other vendors in the space?
I think we're able to offer some sort of pricing benefit, mostly because of the fact that we're, again, a streaming system. We do things incrementally. So instead of rereading the same huge set of data over and over and then shipping it over the wire and incurring a whole bunch of egress fees from our cloud provider to your cloud provider, we're able to actually do most data flows incrementally where we're only pushing new data at any time. And so that really does help and provides a lot of pricing benefits. Usually we see 50% at minimum cost savings between us and unnamed competitors, I'll say. But I think like the thing that's exciting for me is the cost savings. It's just the fact that you can now do more things with the same system, right? Like instead of once you were stuck using something for just analytics purposes, now you can bring it on and actually bring it to the engineering side of the business for software engineering purposes.
Yeah, like for me, like what I'm thinking about is just like I can support all the use cases, like real time and batch, and like yeah, the vast majority of our use cases are batch, but the times where it's real time, it's like typically it's a custom system that gets built out and you've got all this state management and yada, yada, yada that you end up doing. You end up rebuilding the wheel up to different times.
And you have like 3 engineers that are dedicated to like feeding and watering it, right? Like just those 3 engineers that are on that can be building something that was actually helping your business.
Yeah, instead of maintenance. All right. Well, it's been fun to talk to you. So where can people find out more about David and Estuary?
Oh, we're our website's getting better. You know, we spent some time on it, estuary.dev. And so that's probably the biggest one. We're also on, LinkedIn. Those 2 are, we're not too into social, but where we do is probably LinkedIn.
You guys have GitHub, /Estuary as well.
Yeah, exactly. GitHub/Estuary.
And then whenever I work with y'all and stuff, we just talk on Slack. So, there's Estuary Slack.
That's our best place if you want to like speak to someone. Our engineers are actually on our Slack channel, and you can get a response from an engineer like any time of the day, basically.
I've worked with your team a lot, and so very responsive. That's what I'll say. So
I try to promote that culture. I think it's super important.
Well, yeah, it's great to talk to you, David. Hope you have a good day.
Thanks, you too.
That's it for this episode of Data BS. If you enjoyed this episode, make sure you subscribe wherever you listen to your podcast and not miss the next one. This episode was sponsored by CorrDyn, a data consultancy that helps organizations unlock the power of their data. If you have a data challenge, we can help. Visit CorrDyn.com, CorrDyn.com to learn more. See you next time.